Today we are going to discuss some of the problems of aldehydes, ketones, and carboxylic acids lesson. So let me put some questions here and try to yourself to answer them. After that, I will explain to you. And regarding them, if you have any doubts, you can also ask me. So question number one: rate of nucleophilic addition. So I'm giving HCl1OH formaldehyde, and the second one is CH3 C11OH, and the third one is CH3 C11O CH3, and the fourth one is CH3 C11O C2H5, and the fifth one is PHC11OH. So now you have to compare the rate. So which will have the more rate for the nucleophilic addition and which will have the less. So you have to rank them or ordering. So give me the order for the rate of nucleophilic addition. So this is the question. Please answer them. If you don't understand anything in this question, please ask me. I will explain to you. So please tell me the order of the answer. So what is the answer? So you can put the answer in the chat box, like 2 greater than, 3 greater than, 4 greater than, like that. So I'm expecting the answer from your side. So nobody is not responding for this question. So first, let me know, have you understood this question? So please respond whether did you understand or not. Did you understand or not this question? Please answer. At least first you tell whether you understood this question or not. Then we will try for the answer. Yes, sir. Very good. You understood the question. Now try for the answer and put the answer in the chat box. I will look at it and I will explain. If you do the mistake, that also I will clarify to you. Why did you do the mistake? Very good. One student answered the question. I am expecting more answers from other students also. Only one student gave the answer. So what about the students? Very good. The students are leaving the group very nicely. So only two students responded. 1, 2, 3, 4, 5. Because crowding inversely proportional to the nucleophile. Very good. Only two students answer this question. All right. So first, let me tell you the theory. The rate of AN. AN means nucleophilic addition. So rate of nucleophilic addition is directly proportional to the nucleophilicity of nucleophile and directly proportional to the electrophilicity of C double bond O group and hindrance. So this is hindrance at C double bond O. This is directly proportional or inversely proportional? This is inversely proportional. When the hindrance increases, rate of nucleophilic addition decreases. So the rate of addition of nucleophiles depends upon these three factors. Okay. So when the nucleophilicity increases, rate increases when the nucleophilicity increases, and rate increases when the electrophilicity at the carbonyl group increases, and rate increases when the crowding decreases. Right? So lesser the crowding at the C double bond group, more the reactivity. Now in the given compounds, as we know that aldehydes are having less crowding at C double bond group when compared to the less crowding when compared to the ketones. Okay, so ketones are having the R1, R2, more crowding. So ketones are having more crowding. Aldehydes are having less crowding. So less crowding means aldehydes must be having the more reactivity. That means more rate when compared to the ketones. So aldehydes have the more reactive when compared to the ketones because those are having the less crowding, right? So in the given options, the first one is aldehyde, second one is aldehyde, third one is ketone. Sorry, this is ketone, right? First one aldehyde, second one aldehyde, and the third one is also aldehyde. So in this, 1 greater than, 2 greater than, 5 greater than, and next one is ketones. Here two methyl groups and here methyl and ethyl groups. So in that case, we will get the 3 greater than 4. So this is aldehyde set, this is ketone set. So the crowding increases, reactivity, that means rate decreases. Here also the crowding increases, the rate decreases. Crowding is H greater than CH3 greater than pH. So this is simply based on the size factor I explained. Okay. Did you understand this? Please answer this. Have you understood? Any doubts here? Can I go to the next question? Student respond. Can I go to the next question? See, when I ask the question, if you respond, then only I will proceed the class. Yes, sir. Right. So, next question is, so which question number 2, which of the following undergo aldol condensation reaction? Okay. So the first one is formaldehyde. The second one is benzaldehyde. And the third one is Me3C, C double bond OH. And the fourth one is cyclopropanone. The fifth one is you can take some bicyclic compounds like this. And the sixth one is Me2CH C11OH. So find out which of the following will undergo alkyl condensation. So one option may be correct or more than one option. Please select. Students, are you doing this question? Did you understand the question? So which of the following will undergo alkyl condensation? I have given the 3 plus 3. Totally 6 molecules I gave. So what is the answer? One and 3. So 1 and 3. And I'm expecting from everyone only 2 to 3 students are responding and others are not responding to these questions. Please respond and try to learn something. So very good. One student responded and said the answer 1 and 3. So which of the following will undergo alkyl condensation? Compounds containing alpha hydrogen. Yes, compounds containing alpha hydrogen. That is correct statement. But I am asking out of the 6, which will undergo alkyl condensation? Tell me the numbers 1, 2, 3, like that. Six, 4,6. Okay, now let me tell the answer. So aldol condensation can be given by the aldehydes or ketones which have at least one alpha hydrogen. Right now? So now let's look at in which all these 6 which will have the alpha hydrogen. So this is not having alpha hydrogen. So before this, let me tell you what is alpha hydrogen. Alpha hydrogen is nothing but the hydrogen that is attached to the alpha carbon. Hydrogen attached to alpha carbon. Then you will ask the question, sir, what is alpha carbon? Carbon attached to functional group is called as alpha carbon. So for example, if you take C11O, CH3, CH3. So this is alpha carbon, this is alpha carbon because those are attached to the functional group, that is C11O. and this is having the two alpha carbons, and each alpha carbon is having the three hydrogens. Total it is having six alpha hydrogens, right? I hope you understood this one. Then this is not having any alpha carbon, so any alpha hydrogens. So this is also do not have any alpha hydrogens, because if you look at here, one more condition is there to know the alpha hydrogen. This must be sp3 carbon, but here we are having sp2 carbon, right now. So that's why I have taken ch3 ch3. So these two must be sp3 carbon. So that means always alpha carbon is sp3 hybridization, right now. So now this is also do not give aldehyde condensation because it do not have the alpha hydrogen. This is also do not have the alpha hydrogen, so do not give aldehyde condensation. This is having here two alpha hydrogens and here also two alpha hydrogens. So we may expect this can give the aldehyde condensation, but remember this do not give the aldehyde condensation. Why, sir? Even though it is having alpha hydrogens, why it not give the aldehyde condensation? I will explain to you. Just wait a minute. And come to here. Here also it is having alpha hydrogen, and here also it is having alpha hydrogen. But these also do not give the aldehyde condensation. The reason I will explain. And let's come to this one. This is also having alpha hydrogen here. So you may expect this can also give the aldehyde condensation, but this also do not give the aldehyde condensation. So which of the following undergo aldehyde condensation? The answer is none of this. Okay, no one can give the aldehyde condensation. Now let's look at the reasons why this cyclopropanone do not give the aldehyde condensation. Because here we are having the sp2 hybridized carbon, so which is highly having the ring strain. So when we add the OH minus, instead of taking the hydrogen, instead of acid base reaction, the nucleophilic addition reaction will take place here. So why? To minimize the angle strain. So actually it is having, it should have the 120 degrees, but we put them at 60 degrees. Now it is having 109 degrees. We put them at 60 degrees. But the angle strain is too much here because the difference in the angle is too much. Here the angle is less. So to minimize the angle strain, this OH minus will go and attack here. As a result, it will give the sp3 carbon. Now what will happen? This bond will shift to here. Then we will get the this bond shifted to here. Here double bond O, OH, and here we will get the CH2 minus. So this CH2 minus is highly basic in nature, so it will take the hydrogen here. In that case, we will get the CH3, CH2, C double bond O minus we will get. So if you take here NaOH as a base, then you will get the Na plus O minus, right? Next, second one is the bicyclic compound. See, remember there is a rule. So according to that rule, that is called as bent rule. I can also draw like this. I can also draw like this. The same thing, right? So these are the alpha hydrogens, and these carbon atoms are called as bridgehead carbons. And here also this is bridgehead carbon. So this is bridgehead carbon. This is bridgehead carbon. At bridgehead carbon, carbon free radical, carbocation, and carbon ion formation are highly unstable. So OH minus do not come and take the hydrogen from here. So that is the reason why this do not undergo reaction. Now let's take this one. Here, this is nothing but CH3, C, CH3, and hydrogen, and C double one O H. When we take the OH minus, as we discussed just now, the nucleophile can attack easily at less crowded C double one O group, right? So when we take this compound, this is having that 2 methyl group makes the crowding at this carbonyl group. So as a result, this OH minus cannot come and take this hydrogen because of the crowding. Instead of this will go and attack at this position. In that case, we will get the Cannizzaro reaction, Cannizzaro reaction, and not aldol condensation. So do not take place acid-base reaction because here the crowding is there. So this OH minus cannot come and take this hydrogen easily. And instead of that, it will go and attack at this carbonyl group and undergo Cannizzaro reaction. Right? So these are the three reasons for this three molecules. So any doubt here? Please respond. Anybody have any doubt here? So you have to respond. Then only I will proceed. All participants has to be respond. Only we are having just 6 to 7 students only. So please try to interact with me so that I can make you learn more, right? So any doubt, please respond. Sir, can you give examples of pop-up tools? Okay, no doubts are clear, right? I will give with some questions. Okay, right. Now let's discuss some of the questions that are related to the aldol as well as Cannizzaro reactions. So please tell the what is the product in this reaction? CH C double bond O H plus CH3 C double bond O H. So if I take OH minus, so what is the product you can expect here? So write the answer. So this is the first one, and the second one is H C double one O CH2 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 and CH2 1 2 3 4 5 6 7. So this is having the OH minus. So what is the product? Please write it here and write the acidic strength of the CH3 CH2 NO2 CH3 CH2CN and CH3 C double one CH2 C double one O R. CH2 C double one O R. So write the acidic strength of these compounds. Please copy them. And the fourth one is what is the product of this reaction? CH3 C double one O H plus CH3 NO2. So please answer them. Have you completed it? Did you finish them? Second question is intramolecular aldol condensation. Alpha hydrogens are there. So whenever alpha hydrogen is present, you can go to the aldol condensation, no doubt. If alpha hydrogens are not there, then you can think about the Cannizzaro reaction. I give the hints for two questions, not one question. Right? Can I give the answers? Okay, let's look at the answers for this. So alpha hydrogen is present. We will get the CH2CH4 minus. So this will go and attack here. So this reaction is aldol condensation. So you will get CH, CH2, C11OH. So remember, I did not put heating symbol here. So no alpha comma beta unsaturated compounds. If I put the heating symbol here, then only you have to think alpha beta unsaturated compounds. Otherwise, this will give the beta hydroxy carbonyl compounds only, right? Now here also just I have put the OH minus. So let's take this OH minus and take the hydrogen here and form the carbon ion. Then this will go and attack here. In that case, we will get the 1, 2, 3, 4, 5, 6 membered carbon chain. And at the first carbon, you are having the aldehyde group like that only. So 1, 2, 3, 4, 5, 6. At sixth carbon, you will get the OH. So this is the answer for second question. Is it clear? Just now someone asked me about this. Have you got the clarity? Next, acidic strength. So when we use the OH minus, which hydrogen is least taken by this OH minus? So if we form the carbon ion here and here and here. So NO2 is a strong minus M group and Cn is also strong minus M group. When compared to the NO2, Cn minus is less. When compared to the Cn, CO group is less minus M group. So the strength of the minus M effect is like this. So this is the acidic strength order of the hydrogen of this alpha carbons. Now let's look at the fourth question. CH3 C11OH plus CH3NO2. In these two, you may confused when I use, sorry, here I didn't give the reagent, that is OH minus. So which hydrogen easily taken? The hydrogen which is more acidic, that hydrogen first taken. So this is more acidic. That's why I have given this question. So then you will get the negative charge here. This will go and attack here. In that case, we will get the CH3, COH, H, CH2, NO. Like aldol condensation only. This is with respect to the nitro compounds, right? So, any doubt in these four questions? If you have any doubt in this, please ask me. I will explain. Okay, right. Now, let's do some other questions. So, what is the product of this reaction? Please tell me. So, I think these are all you have learned in your class itself. So, what is the answer to this? And CH3, C11O, CH3, and this one is OD minus D2. So this is first question, this is second question, and the third question is O3. Second one is zinc H2. So please answer there. Then we will discuss about the answers if you don't get. So in the last 5 minutes, I will explain the pop-up rules. So don't worry. So please tell me if you have any other doubts also regarding this lesson. I'll try to clarify. That question is CH4, CH2 taking 4, CH4. Third question. Both are aldehydes you are saying. Please look at once again. Check your answer. So now let's discuss about the first question. So when we use the wedge minus, that means aldol condensation, we expect that hydrogen will be taken from here. So we may get like this. So this is what we expected. So but the thing is, this is anti-aromatic compound. See, 4 pi electrons are there. So anti-aromatic compounds are highly unstable. So that's why this enolate in aldol condensation in the first step, what we will get? Enolate only we will get. So here this enolate is very highly unstable. So the reaction mostly backwarded only. So that's why this do not undergo aldol condensation. Right? Next thing is OD minus D2O. When we take OD minus D2O, directly do not undergo aldol condensation. First, all the hydrogens will be replaced by the deuterium atoms. Then this will undergo aldol condensation. So generally, students will think that in the OD minus will take the hydrogen and let's do the aldol condensation here. But that is wrong. First, this OD minus will take the hydrogen from here, then CH3, C11O, CH2 minus we will get, This will take the deuterium atom from the D2O, then we will get the CH2D. Like this, all the alpha hydrogens will be replaced by the deuterium atoms. Then we will get this one. After the formation of this, then only aldol condensation will take place. Okay. Next, come to the this one, ozonalysis. So as you know that simple technique in the ozonalysis, this is reductive ozonalysis. That means in the reductive ozonalysis, we will get the aldehydes plus ketones. In oxidative ozonalysis, generally it happens in presence of O3 and ZCP H2O. In oxidative ozonalysis, we will get the in the reductive ozonalysis, we will get the aldehydes and ketones as said. So CW1O and this one will get the H2. So this is the compound we will get here, right? Next, let's do some more questions. So before this, let me tell you pop-up story. So this is pop-up story. Let's discuss. See, according to the pop-up story, during oxidation of unsymmetrical ketones. So what are unsymmetrical ketones? The C11O group is having the two different groups. Left side is different and right side is different. So example is CH3, C11O, CH2, CH3. So these are unsymmetrical ketones. Then the C11O group remains with the smaller chain. With the smaller chain. So for example, let's take this compound CH3, C11O, CH3. Okay, this is symmetrical ketones. So in the symmetrical ketones, when undergo oxidation, we will get the CH3. So bond can be broken here or can be broken here. Wherever it is broken, we will get the compound CH3, COH plus HCW1O, HCW1OH. Okay, so first let's try to understand with symmetrical ketones. The next to CH3, CH2, CW1O, CH2, CH3. The same thing. CH3, CH2, the bond can be broken here or here because both are having the same groups to the left and right side. That is symmetrical ketones. In that case, we will get the same products. So CH3, CH2, and this can be CW1OH, right? So this is having 3 plus 3, 6. Sorry, here it is only just 3 plus 2, 5 only. Right now, let's look at for unsymmetrical ketones. CH3, CH2, CW1O, CH2, CH2, CH3. This is having the 3 carbon chain. This is having the 2 carbon chain. So that means the carbon chain is different. So this is called as unsymmetrical ketones. In the case of unsymmetrical ketones, this C11O group is remains same with smaller chain. So this is the smaller chain. So this will be given to this smaller chain. In that case, we will get this CH3, CH2, C11O. In the oxidation, we will get the what? Just now we have discussed. In the oxidation, we will discuss acids. We discussed that in the oxidation of the ketones, we will get the acids. So here, this will be taken to this smaller group OH plus 1, 2, 3. CH3, CH2, CW1OH. Right? So this is about the pop-up story of stool says that the C double bond group must be taken with smaller chain. So let me take another example. CH3, CH2, CH2, C double bond O, and CH2, 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 and CH2, and CH2. So this is having 3 plus 2, 5 membered, and this is having 3 membered. So this is 5 membered chain, 3 membered chain. Now C double bond group must be taken with this one. In that case, we'll get this CH3, CH2, CH2, C double bond OH plus again this one CH3, CH2, 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 5 membered, 4, 5 membered OH. So, right? Did you understand? Someone asked this question. Sir, could you explain order condensation in acidic medium? Right? So, first, did you understand this one? So, someone asked me about this pop-up stool. Right? So, acidic medium, let's try to understand the order condensation mechanism in acidic medium. Let's take the CH3, C double bond O. Oxygen is having the 2 lone pairs. So let's take the dilute express. As we know that oxygen is having 2 lone pairs, it can donate its lone pair to the hydrogen. In that case, we will get the positive charge in the oxygen, right? So this is called as what? Protonation. So this is called as protonated carbonyl. Protonated carbonyl. So now what will happen? This will give the CH2. So that means enolate is there. No? So what is the enolate? Let's take this one. Let's form the enolate here. In that case, we will get the CH3, CH2, double bond C, OH, and CH3. So this is what enol. So if we use the base, we will get the enolate. Here we will get the enol. Right? Now this is going to react with the compound. So which compound? Let's see. CH3, C double bond O, CH3. Now this will shift here. This will come here. In that case, we will get the CH2 minus C double bond O. So after removal of H plus, we will get the CH3. So this will go and attack here. So CH3, C O minus CH3 and CH2, C double bond O, CH3. Right? It can take the H plus. In that case, we will get the CH3 OH, CH2, C double bond O, CH3. Right? Any doubt? So someone asked me, have you got the clarity? Or did we replace hydrogen with CH3 protonated carbonyl? How did we replace hydrogen with CH3? Oh, sorry, this is hydrogen itself, right? Don't worry. This is hydrogen. Just I made a mistake. Okay, so I thought it is ketone, right? Right. Any other doubts you have? Please ask me, I will explain to you. So can I ask some other questions? So let me put some interesting questions, twisted questions. So you tell the product of this reaction. So what is the product of this reaction? At 5 degrees centigrade, please guess the product of this reaction and the product of this reaction also. So this is which ones, and I am going to hit this also. So please answer them. So have you tried? Anybody got answer? So now I'm going to explain. So the first thing is here we have taken OH minus is base. So first this acid base reaction will take place here. This is acidic in nature, this is basic in nature. In that case, I will get the short form only. So this is generally 3-membered and 4-membered rings are highly unstable because of the ring strain. So they will easily undergo reactions. For open the ring, in that case, this bond shifted to here and this bond shifted here. So then I will get the CH3 here, C double bond O, and this one is negative charge here, here negative charge, and C double bond O and CH3. So this can take the hydrogen from water that is released here. In that case, we will get the neutral carbon. This is negative charge, and then we will get this. Now, is there any possibility for the aldol condensation? Yes, because it is also having the alpha carbon atoms. So the OH minus, we take the hydrogen from here, then we will get the double bond over here, CH3, and this one, and double bond over, and the CH2 minus. Now 1, 2, 3, 4, 5, 6. If we go in this way, we are getting 5-membered ring. And if we start from here, 1, 2, 3, 4, 5, 6-member we are getting. So it's better to remove the hydrogen from. So anyway, both are same only, right? Just look at here. Something I think I made a mistake. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Then here something is, this is wrong, I think. So let me write in the next slide. So this is the OH and C double bond O. Then OH minus will take the hydrogen here. Then we will get the O minus. C double bond O CH3. This is there. This will shift to here. Then we will get the double bond O here and CH2 minus and C double bond O CH3. So whatever the minus H2 is there, that will react with this one. Then we will get the C double bond O and C double bond O CH3. Now you can take the hydrogen from any carbon, right? In that case, I'm going to take the hydrogen from this carbon. So 1, 2, 3, 4, 5, 6, 7. And after removal of the hydrogen, you will get the negative charge here, C double bond O, and this is what we will get. And this will come and attack at the 6th carbon. So we will get the 6-member chain. And in the second carbon, so let's look at here 1, 2, 3, 4, 5, 6, 7. In the first carbon, let's assume that this is first carbon, this is second carbon, third, fourth, fifth, sixth. In the sixth carbon, we will get the OH and we will get the CH3. So this is the possible product we can expect, right? Anybody got this answer? Nobody is not responding. I think nobody can get this answer. So next question is this one, right? So first, what will happen? OH minus we are taking. Let's look at any alpha hydrogens are there. So alpha hydrogens are present here. This will be negative charge. This will get the negative charge, and this will go and attack here, and this will go and attack here. In that case, we will get the compound like this: EH, EH, and EH, OH, and this is OH, EH. But I put the heating symbol, so you have to remove the H2O. So we'll get the double bond here, EH, EH, and double bond. So hydrogen from here and OH from here will be lost. We get the double bond here and we will get the double bond here. Right? So at least tell me how many of you got the correct answer for this, at least for second. Anybody got the answer? Same answers? Okay. Or else please let me know if you understand these two questions or not. So nobody is not responding. What happened? Understood, sir. Only one student responded. What about others? Sir, why these compounds are written in aromatic form are? So I will tell you. The last compound is this one. Here hydrogen is there. Here OH is there. When we heat, what will happen? The hydrogen and the OH both will be left. That means both will be removed. So as a result, we will get the one pi bond here. And here also hydrogen, here also OH. When we heat, we will get the pi bond here. This is what happened in Aldol condensation, right? And this is taking place in presence of OH minus. So even CP mechanism is there, right? According to that, we will get the double bond here. So did you get the answer for your question? So can you please show first question slide? First question means, so which one? First question means which one? I don't understand. This one, right? So this is last slide. This is the last slide, and this is the answer for first question. Okay. So before the close of this session, please let me know any doubts in this. Have you understood anything from these all questions? So for me, molecular formula is coming same, whether it is correct. Molecular formula. Why did you go for molecular formula? So for me, molecular formula is coming same, whether it is correct for second question. So why the molecular formula came into the picture? Okay. So any doubts? Please tell me. Okay, students. So I'm going to close the session. Thank you very much for your participation. Ranjit sir. Thank you. Ranjit sir.
Yes, sir. Yes, sir. Thank you.
Can I